Hello everyone, welcome back to the channel. Today we are going to tackle an interesting coding problem called minimum number of days to make M bouquet. This is a common algorithmic problem that involves array and binary search, and it's a great way to sharpen your problem solving skill. Let's right into it. Understand the problem statement. Imagine you have a garden with n flowers and each flower blooms on a specific day given by array bloomDay. The ith flower bloom on bloom day I. You want to make m bouquet and each bouquet needs k adjacent flowers. The goal is to determine the minimum number of days you need to wait to be able to make the M bouquet. If it's impossible to make M bouquet with the given flowers, you should return -1. For instance, let's take an example. Bloom day equal to 1, 10, 3, 10 and 2, where M equal to 3 and K equal to 1. In this example, we need 3 bouquets and each bouquet needs 1 adjacent flowers. However, there are only 5 flowers in total, which make it impossible to form the required 6 flowers. Thus, the output is -1 we want. 3 we want. To solve this approach, we can use a binary search approach. The idea is to determine the minimum number of days required. We will set our search range from the minimum possible day 1 to the maximum possible day, which we can assume to be large number. Then we iteratively narrow down the range until we find the optimal solution. Let's write the code. L R equal to, where L equal to 1 and R equal to 9. Answer we get -1. While for L less than equal to R, we find midpoint where M equal to L plus R minus 1 divided by 2. For bloom in bloom day, if bloom had midpoint we write consecutive length 1. If consecutive length is greater than equal to k, then consecutive length equal to 0 and bouquet increment by 1, else consecutive length equal to 0. If bouquet greater than equal to mid, which is m, answer equal to mid, and right r equal to mid minus 1, else l equal to mid plus 1. Then we return answer. So what happened here? First we set the left one L to 1 and the right R equal to 1 9 times 0. ANS answer is initialized to minus 1, which will store the minimum number of days if it's possible to make the bouquet. Then we continue the loop as long as L is less than or equal to R. We then calculate the midpoint of the current range. After that, we checking the feasibility. For each day in bloomDay, check if it's less than or equal to mid. If it is, increment the consecutive length if consecutive length reaches to k point. Then we increment the bouquet and reset the consecutive length. After that, we search the range. If the number of bouquet form is greater than or equal to m, update answer to mid and search in the left half by setting r to mid minus 1. If not, search in the right half by setting L to mid plus 1. In that result, after executing the loop, return answer. If it's still minus 1, it means it is impossible to make the required bouquet. In conclusion, that a brief overview of the problem and the solution. This approach efficiently narrow down the minimum number of days needed using binary search, making it much more optimal than a brute force approach. Let's run the code. There is some error. Just find out. Okay, there is one spelling mistake. Let's run the code again. Okay, there is some wrong answer. Let's run the code again. Okay, it accepted. Let's submit the answer. Okay, it accepted. If you found this explanation helpful, don't forget to like, share and subscribe for more algorithm explanation and coding tips. Happy coding and see you in the next video. Thank you.